For the rest of this lecture note, we are going to talk about algebra, especially multiplying, dividing, adding, and subtracting complex numbers. The first one is we have two complex numbers, z1 equal to square root of 3 plus I and z2 equal to 1 plus square root of 3i, and we are going to represent these complex numbers in polar form and perform the product, the division of the first complex number by the second one, and find 1 over the second complex number. So first, remember, we're going to write each of these complex numbers in their polar form. So when I'm doing z1, both x and y are positive. So I'm thinking about x equal to square root of 3, y equal to 1. So clearly I can say that the radius is square root of 1 squared plus square root of 3 squared, so 1 plus 3. And that's square root of 4, which is 2. Tangent theta is 1 over square root of 3, which is pi over 6. So that's pretty set at this point. And I should not say pi over 6 there, I just should say theta equal to pi over 6. So z1 is the complex number. I can write it as your radius is 2 cosine pi over 6 plus I sine pi over 6. And then I have z2. Similarly, that's also going to be in the first quadrant. This time, the only change is in the theta. Remember, your x and y are still 1 and square root of 3. So you get 2. So I'm not going to do that work again. So this is square root of 3 and this is 1. So tangent theta is square root of 3. So theta is pi over 3. So I get to say that z2 is the complex number given by 2 times cosine pi over 3 plus I sine pi over 3. So according to the formula, z1, z2 is going to be 2 times 2, so 4, cosine pi over 6 plus pi over 3. So that's pi over 6 plus 2 pi over 6, which is pi over 2. So if I want to say that first, pi over 6 plus pi over 3 plus I sine pi over 6 plus pi over 3. Then remember, I have to find the common denominator. So I get to multiply 2 on top and bottom of the second fraction, and I get pi plus 2 pi, which is 3 pi over 6, and then 3 cancels from the top and bottom and gives you pi over 2. So I'll simply say that this is cosine pi over 2 plus I sine pi over 2, the same thing. Cosine pi over 2 is 0, sine pi over 2 is 1, so I get 4i. How about z1 over z2? If you remember, this one is a subtraction. So first and foremost, we do 2 over 2, cosine pi over 6 minus pi over 3, plus I sine pi over 6 minus pi over 3. So this angle is minus pi over 6. I might want to write it one more time as cosine of minus pi over 6. Remember, cosine is even, plus I sine minus pi over 6, and that is odd. Sine is odd. So I get minus square root of 3 over, so positive square root of 3 over 2, because cosine being even, cosine minus pi over 6 is cosine pi over 6. Whereas sine being odd, the minus comes out, and I get minus 1/2 times I. So that's z1 over z2. Now remember, 1 over z2, it's z bar, z2 bar, over the modulus of z2 squared, or r squared. So if you think about this, z2 bar, my z2 was 2 times cosine pi over 3 plus I sine pi over 3, or you can actually think about 1 plus square root of 3i, doesn't matter which form you want to take. So then the conjugate is 1 minus square root of 3i, and the modulus we found out is 2, so it is 2 squared, so 4. So this is 1 over 4 minus square root of 3 over 4i. So that is 1 over z2. And this is the work that we will repeat for a couple more problems. So the next one is complex numbers square root of 3 minus 3i. As usual, I'm going to do the work for Z1 first. The X is positive, Y is negative, so we're in fourth quadrant. X is square root of 3, Y is minus 3. So R is going to be square root of 3 square plus negative 3 square, which is 3 plus 9, and that's square root of 12, which is 2 square root of 3. Tangent of theta is going to be negative 3 over square root of 3, which is negative square root of 3. So the reference angle is pi over 3. The angle in the standard position is 2 pi minus pi over 3. So theta is 2 pi minus pi over 3, and that's 5 pi over 3. That's my Z1. So I get to say that Z1 as a complex number is going to be 2 square root of 3 cosine 5 pi over 3 plus I sine 5 pi over 3. Z2, the complex number Z2 has X negative, Y positive. So I'm in the second quadrant, and both of them are 1. So negative X, positive Y. So R is negative 1 square plus 1 square, and that's square root of 2. Finally, we're going to work out for the theta measure. So tangent of theta is 1 over negative 1. So negative 1. So theta will have the reference angle of pi over 4. So this is pi over 4. But I want the angle in the standard position. So that's pi minus pi over 4. And I get to say that this is 3 pi over 4. So the complex number Z2 is square root of 2 cosine 3 pi over 4 plus I sine 3 pi over 4. So when I do the product Z1, Z2, I get 2 square root of 6. That's a multiplication of the absolute values. Then I get cosine 5 pi over 3 plus 3 pi over 4. If you want to know the value, you can use the sum formula plus I sine the same angle 5 pi over 3 plus 3 pi over 4. Again, we're just looking forward to find the common denominator. That's 12. So you multiply 3 on top and bottom of the first fraction and 4 on top and bottom of the second fraction. And I get 2 square root of 6 cosine 15 plus 12, so 27 pi over 12. Actually, should have done the other way around. So I did the common denominator wrong. Let me do it one more time. So you had 5 pi over 3 plus 3 pi over 4. I should have multiplied 4 on top and bottom on the first one and 3 on top and bottom on the second one. Okay, so and how much should I get then? So 5 times 4 is 20, 3 times 3 is 9, so that's 29 pi over 12. And that's going to be the same angle for the other one. So plus I sine 29 pi over 12. And I'm going to skip the work for finding and simplifying these values. Z1 over Z2 is 2 square root of 3 over square root of 2 cosine 5 pi over 3 minus 3 pi over 4 plus I sine 5 pi over 3 minus 3 pi over 4. So if I rationalize, I will multiply square root of 2 on top and bottom, and I will get square root of 6 times. Now same thing, you can multiply 4 on top and bottom of the first fraction and 3 on top and bottom of the second fraction. So it is going to be 20 minus 9, so that's going to be 11 pi over 12. So cosine 11 pi over 12 plus I sine 11 pi over 12. And remember, to find these exact values, I can use the sum and subtraction formula for trigonometric functions. To approximate them, you can use a calculator. And finally, we'll do 1 over z2. Just remember the formula is z2 bar, and the complex number z2 is -1 plus I. So the conjugate is -1 minus I over the modulus, which was square root of 2 squared. So I get to say that this is -1/2 minus 1/2 I. And that will be 1 over z2. Okay? Our next problem is going to ask us to find the same things. This time z1 is -40 and z2 is square root of 3 plus I. So z1, -40 means I am a quadrant angle. It's in here. So easier because the radius is 40 units. Theta is equal to pi. So I can write z1 equal to 40 times cosine pi plus I sine pi. Z2, whereas, is going to be in the first quadrant as both x and y are positive. X is square root of 3, y is 1. We have done this previously and we know that I is 2. Tangent theta is 1 over square root of 3, so theta is pi over 6. So the complex number z2 for us is 2 cosine pi over 6 plus I sine pi over 6. So z1, z2 is 2 times 40, which is 80, cosine pi plus pi over 6 is 7 pi over 6, plus I sine 7 pi over 6. Now this one is easy to find the exact value because these are standard angles. 7 pi over 6 is in the third quadrant. Cosine sine both are negative with the reference angle of pi over 6. So I get to say that this is minus cosine pi over 6 minus I sine pi over 6. So 80 times cosine pi over 6 is square root of 3 over 2 minus 1/2 I. Divide by 2 and you get minus 40. And I also factored out the minus times square root of 3 plus I. z1 over z2. So we're going to divide 80, 40, the radius of the first complex number, by 2, the radius of the second complex number, and subtract the angle. So I get pi minus pi over 6. So that's 5 pi over 6 plus I sine pi minus pi over 6. So since it is pi over 6 and it's in the second quadrant, cosine negative, sine positive, I will go ahead and say that this is 20 minus cosine pi over 6 plus I sine pi over 6. So minus 20, the same values, minus square root of 3 over 2 plus 1/2 I, and then again I can factor out the minus and divide by 2, so I get positive 10 this time, square root of 3 minus I. And 1 over z2 is the easier one. You can just go ahead and to your complex number z2, which is square root of 3 plus I, take its conjugate, so square root of 3 minus I over 2 squared. So I get square root of 3 over 4 minus 1/4 I as 1 over z2. Now this problem, I have given you the polar form, so it's even easier. We'll start with z1, z2 formula wise and see for the first complex number, if you are thinking about the radius, it's 1 unit. Second complex number, the same thing, it's 1 unit. So I will say it's 1 times 1, so 1 cosine 5 pi over 6 plus pi over 6. That's adding plus I sine 5 pi over 6 plus pi over 6. I should have said pi over 6 plus 5 pi over 6, but they're the same thing. So this is cosine pi plus I sine pi. So that's -1. Whereas z1 over z2, now we are subtracting. So we will do cosine pi over 6 minus 5 pi over 6. Again, the radius being 1 in either situation, 1 over 1 is 1 and I didn't write it. Plus I sine pi over 6 minus 5 pi over 6. And remember, even odd for cosine and sine respectively. So you get cosine minus 4 pi over 6 plus I sine minus 4 pi over 6. Now 4 pi over 6 is 2 pi over 3. 2 pi over 3 is in the second quadrant. The reference angle is pi over 6. So I can say that this is pi over 3. I'm so sorry, reference angle is pi over 3. So let's first use the evenness and call it cosine 2 pi over 3. And minus I sine 2 pi over 3. As I said, 2 pi over 3 is in the second quadrant, cosine negative, sine positive, and the reference angle is pi over 3. So I would say that this is minus cosine pi over 3 minus I sine pi over 3. Cosine pi over 3 is 1/2, so minus 1/2 minus sine pi over 3 square root of 3 over 2 I. 1 over z2. 1 over z2 is going to be cosine 5 pi over 6 minus I sine 5 pi over 6. Remember, the modulus is 1. So even if I'm dividing by 1 squared, which doesn't change anything. 5 pi over 6 is in the second quadrant. Reference angle is pi over 6. So I get minus cosine pi over 6 minus I sine pi over 6, as sine is positive in the second quadrant. So that's minus square root of 3 over 2 minus 1/2 I. Answers my question. Okay, so we will carry on to our next problem. This one is saying, write the complex number in polar form with argument theta between 0 and 2 pi. So it's pretty similar to the work that we have been doing. First and foremost, I would like you to distribute this I and write it as 2I minus 2I squared. Now remember, I squared is negative 1, so I get 2I plus 2. Write it as 2 plus 2I. So x and y are both positive. I'm in the first quadrant, both of them are 2. So r is equal to square root of 2 squared plus 2 squared. So that's 4 plus 4, 8. And that is 2 square root of 2. Tangent theta is 2 over 2, which is 1, first quadrant. So the angle is pi over 4. Pretty simple. So now I get to say that this one is 2, is the radius. Square root of 2, I'm so sorry. 2 square root of 2 is the radius. Cosine pi over 4 plus I sine pi over 4, and that answers my question. Similar question in the next one. You have 6 times square root of 3 plus I, so you call it 6 square root of 3 plus 6I. Both x and y are positive, so I'm in the first quadrant. Y is 6, x is 6 square root of 3. So r is going to be square root of 6 squared plus 6 square root of 3 squared. So that's 36 plus 108, which when added gives us 144, so that's 12. So r is 12 units. Whereas tangent theta is 6 over 6 square root of 3, and that's 1 over square root of 3. Theta is pi over 6. So this is going to be 12 cosine pi over 6 plus I sine pi over 6. Next complex number is 4I. So write it as 0 plus 4I. And why I do that, so that I understand the x and y coordinates. It's 0, 4, so I'm here. And that's pretty simple because the radius is 4 units. So I is 4. And think about the angle, that's pi over 2. So I'm done, then I'm there. So I call this one as 4 cosine pi over 2 plus I sine pi over 2. Write the complex number in polar form with the argument theta between 0 and 2 pi. 3, write it as 3 plus 0I. So now you know that this point is on the real axis with radius 3 units and theta equal to 0. So I call it 3 times cosine 0 plus I sine 0 in the polar form. Okay. sketch the set in the complex plane. So I'm talking about all the complex numbers a plus bi, where a is greater or equal to 0 and b is less equal to 0. So a being the real part, greater or equal to 0 means I will be on the positive direction of the x-axis and I will be equal to 0 as well for my x value. So this is what I'm thinking of. Whereas b is less equal to 0. So y, I'm going to be less equal to 0. So I'm choosing this side and I can be equal to 0. So I'll put closed dot on the x-axis. So where two colors are matching is the fourth quadrant, and that's going to be the correct domain for us. So this one is the correct one. Alrighty. My next problem is asking me to plot the complex number negative square root of 7 plus 2 square root of 3i. All I need to understand is that x is negative, y is positive, so I must be in the second quadrant. So the fourth picture is the correct one. It's very simple. Similar problem. Find the modulus. Modulus of this complex number is going to be x square plus y square. So you will say square root of, now remember your x was negative square root of 7 square plus your y in this problem is 2 square root of 2 over 3. So square root of 2 over 3 square, which is going to be square root 7 plus 2 over 9. So when I find the common denominator, I get 63 plus 2, which is 65 over 9. And that is square root of 65 over 3 units. So this one says that sketch the complex number z and the complex conjugate on the same complex plane. So your complex number is negative 2 plus 7i. Second quadrant, x is negative, y is positive. And z bar is going to be negative 2 minus 7i. So both x and y are negative, so that should be in the third quadrant. So just by looking, I already know that the third one is the correct choice because z is in second, z bar is in the third quadrant. That answers my question. And that also concludes our study of complex numbers. And essentially at this point, we are confident enough that we can say that we have learned enough trigonometry to help us during our calculus classes. And for our next few videos, we will talk about conic sections. We will do circle, parabola, ellipse, and hyperbola.